Alrighty, so now we are back. So for this one over here, right, do you notice something different? Well, the difference that we have over here is a negative symbol. And then at the bottom, we still have a multiplication only, right? But we are more focused on that negative right there. So for what we are going to do is we are going to find out a way to simplify this expression so that we're able to get to a more simpler answer. And this is where your knowledge on finding highest common factors is going to be the most important step of all. So let's get straight into all of this. Okay, so here is the steps that I will give you in order to simplify these types of questions. So all we need to notice is that there is not much we can really do about this. But what we remember is our laws of addition and subtraction within exponents. So remember that if we have x to the power of n multiplied by, or let's do it the other way around, n plus m, this is the same as x to the power of n multiplied by x to the power of m, right? So we're just going to do that. So let's just do that, right? In the numerator, we are going to have 5 raised to the power of 1 multiplied by 5 raised to the power of 2x. Do you notice that there's an addition between the 1 and the 2x? And the base is going to stay the same as 5. Okay. And that is essentially what we just did right now, okay? And then we're going to continue with the other one. So you always look out for the arithmetic or the addition or subtraction of exponents and split them up in this way over here, okay? Promise me you'll remember that. Now we subtract this by 3 multiplied by 5 to the power of 2x, so nothing really changes there. And even at the bottom, there's no other exponent that has 2 or more variables or terms, 25 to the power of x multiplied by 4, and then we are just gonna finish off by dividing it. Okay, now from here, what do we notice? So we notice something over here, right? Here we have a prime number, we have a prime number, prime number, prime number, okay? All of them at the top are prime numbers. Now notice that these two values, this one and this one, are not prime numbers. So we need to break them up into prime numbers, okay? So what we are going to do is we are going to do the following. So I'm just going to skip to the part where I get to the denominator. We need to remember with the denominator, right? We have 25 raised to the power of x, okay? And then all we need to do is we need to say over here that 25 can be rewritten as 5 to the power of 2, and this is all raised to the power of x, multiplied by, what can 4 be written as? 2 squared, right? So that's what we have. And from here, we need to notice something, okay? We are going to simplify this part over here, such that all we are going to have is the following. So once again, cut through. We notice that the law of multiplication of exponents is being used. So we are going to multiply the 2 into the x outside. So therefore, it's going to be 5 to the power of 2x. I'm seeing a little bit of a pattern here. I don't know about you. Multiplied by 2 squared, okay? So that's what we have. Now let's go to the common factors. So let's just quickly go over what we have looked at so far. So far we have taken the exponents that have multiple terms and broke it up, right? And then from there we looked for we want to convert everything to prime factors, right? And then we got to this point here. And then we simplified to get to here. Do you notice that at the top of this expression here, right, of the numerator, this numerator here, this term, 5 multiplied by 5 to the power of 2x, minus the other term, which is 3 multiplied by 5 to the power of 2x, do you notice that this 5 to the power of 2x is a common factor? So let's take out that common factor and see what happens. So when we take out the common factor, notice that we are going to have 5 to the power of 2x, square bracket or whatever bracket you like using, and then we're going to be left with what? We got rid of this and this as a common factor, So therefore, we're going to be left with 5 to the power of 1 and 3. So minusing 3. I'm going to get rid of the exponent and just say 5 minus 3. Okay, and this is all divided by 5 to the power of 2x multiplied by 2 to the power of 2. Okay, so because I don't see I'm going to really be doing anything with that 2 to the power of 2, I'm just going to rewrite it as 4. But for now, I'm just going to leave it as 2 to the power of 2, so that you can see what we're really dealing with. Okay, so let's continue. Do you notice that we can cancel these out? You could do exponent laws and do all of that, but that is a very unnecessary step in this situation. You can do it if you want to though. But right now, do you notice that we can cancel out the 5 to the power of 2x now? That's actually perfect. That's what we really want to do. And then therefore, we are left with 5 minus 3 over 2 squared, which is the same as 5 minus 3, which is equal to 2 divided by 2 squared, which is just 4. And this can be simplified to a half. So therefore, the final answer to this one is just a half. So let's once again backtrack the steps, and then we'll do the next example just out of what we know. In the beginning, we find the terms that have we find the exponents that have multiple terms, right? And then from here, we just split them up, like what we used over here for the rule. So we have 5 to the power of 1 multiplied by 5 to the power of 2x. And then from here, we split everything up into its prime factors, and then we simplified, and then we took out common factors. And then when we take out the common factors, we should be able to cancel something out. Within your curriculum, they have to do that because you guys are in the learning phase, right? They have to find something which you are able to simplify. And then from there, cancel these out and just simplify with easy mathematics from here. Let's do the next example and see where it takes us. Okay, so here is a step where a student would probably go ahead and say, oh, cancel, haha, cancel, cool. Answer is equal to nothing. What the heck, man? I will personally take a visit to your school if you end up doing that, even after this, if you watch this video. Okay, I'm just joking. I don't even know where you are. But anyway, let's just go over this actual question. Let's look at what we need to do. If you remember from the last question or the last example, we split up the exponents using exponent laws. So let's do that for every single one. 3 to the power of 2x plus 2. Okay, so this is what we are going to have. We are going to say 3 to the power of 2x multiplied by 3 to the power of 2, because remember we have an addition sign here. If we had a minus sign, we would say 3 to the power of 2x divided by 3 to the power of 2, but we have a plus sign, so we are multiplying it. Okay, so this is adding by 3 to the power of, now for this one we have 2x plus 1, so therefore we are just going to say 3 to the power of 2x multiplied by 3 to the power of 1. Okay, so we're just going to keep using that exponential law to answer this question. And then we're going to do the same here with the bottom one. 3 to the power of 2x multiplied by 3 to the power of 2. And this is subtracting by 3 to the power of 2x multiplied by 3 to the power of 1. I'm pretty sure you guys get the point of this right now. Okay, and from here, do you notice that every single base is a prime number? Okay, so because they're all prime numbers, we're going to skip to the step where we have to factorize. Do we have common factors in the numerator and the denominator? Yes, we do. We do have common factors. And if you notice, the common factors that we have is 3 to the power of 2x here for these two terms, and for the two terms of the denominator, also 3 to the power of 2x. So therefore, we are going to take those common factors. I guess I'll keep it circled for now. And then we will have 3 to the power of 2x, and then open bracket, and then we are just going to put on what is left. So we just left with 3 to the power of 2 plus 3 to the power of 1. Okay, so I'm just going to do that. So 3 to the power of 2, which is equal to 6, plus 3 to the power of 1, which is equal to 3. Okay, and then from here, we are going to say divided by 3 to the power of 2x is also the common factor here. And then from here, we are just going to show what we are left with. So it's going to be 3 to the power of 2 minus 3 to the power of 1. That is what we are left with. So therefore 3 squared is just equal to... Did I say 3 squared is equal to 6? What is wrong with me? 3 squared is actually equal to 9. I know you're probably screaming through the screen over there. Also, I think the previous video I said 3 to the power of 3 is equal to 9. I'm so smart, you know what I'm saying? Like, I should actually apply to very high-end universities, you know? We're going to have 9 minus 3. Okay. You know, sometimes mathematics is a very mental type of thing, so you need to be prepared. Anyway, let me stop yapping. 3 to the power of 2x and 3 to the power of 2x can cancel, okay? Such that what we are left with is 9 plus 3 over 9 minus 3. So 9 plus 3 is equal to 12. Divided by 9 minus 3, which is just equal to 6. 12 divided by 6 can simplify into 2 divided by 1, which is just 2. Because notice that 6 can go into 12 2 times. And therefore, that is the answer. Very simple types of questions that you'll get. It is not that difficult. You just need to follow these steps and everything will be okay.